So we have another system of mass, wedge and pulleys. This is mass m, this is mass 2m, and we have a system of pulleys and a wedge of inclination 30 degree, and we need to find out the acceleration of the block of mass m. Now for finding out the acceleration of block of mass m, we first mark the tensions. This is T, this whole is one string, the pulleys and the strings is massless, therefore all these tensions are equal to T. This is a different string, therefore we assume this tension to be T dash. Now let us first consider the diagram for this pulley. This pulley experiences tension T upwards, again tension T upwards, and a tension T dash below. Tension is always a pulling force, and it pulls this also, it pulls this also. Therefore this force is tension. Now this pulley is massless. Therefore the net force on this object is T dash minus 2T is equal to mass is 0 into A. That is equal to T dash equal to 2T. So by applying equation on this massless pulley, we get the relation between tensions in the two strings. This is generally the method we use to find out the relation between tensions in different strings. Therefore the relation we get is T dash equal to 2T. Now let the acceleration of this block is A. Let the acceleration of this block be A dash. Now let us consider this string. Its length is L1. The length of this part of string is L1. The length of this part of string is L2. And the length of this part of string is L3. Now this whole string is 1. Therefore L1 plus L2 plus L3 can be written as a constant. We differentiate it 2 times to get L1 double dash plus L2 double dash plus L3 double dash equals 0. Now L1 double dash is the acceleration with which this length of the string changes. Now this pulley is fixed, therefore this changes with minus A. L2 double dash, this pulley is fixed, but this pulley moves with A dash, because this mass is moving with A dash, and this is one string. Therefore this pulley moves with A dash, and it increases this length L2 by A dash. Now for L3, the same case as L2, this pulley is doing the job of increasing this L3 by the rate A dash again. Therefore we write this, and we get A is equal to 2 times A dash. This is another important result which we get. Now this method is known as string constraint, and the string constraint is always used to find out the relation between the accelerations of the various blocks. Therefore A is equal to 2 dash. Now we write the equation for this block along the incline. That gives us T minus mg sine theta, that is mg sine 30 degree, is equal to m into A. Now by applying equation on this block in vertical direction, we get 2mg, that is the gravitational force on this object, minus T dash, that is equal to 2T, is equal to 2m into A dash. A dash is equal to A by 2. So now we have two equations and two variables, that is T and A. We can solve these two linear equations to find out our answer. So our answer stands as, we can write the first equation as T minus mg by 2 is equal to ma, and the second equation as 2mg minus 2t is equal to ma. By multiplying this equation by 2 and then adding these two equations, we get A is equal to g by 3. So a final answer for the acceleration of this block comes out to be g by 3 in upward direction.